Hello guys, welcome to this lecture. I think we started with recursion before few videos, and we have seen the introduction of recursion and also about types of recursion. And suddenly what we did is that we took a concept of uh, time complexity analysis, and we found a method called recurrence relation, which can be used to find the time taken by a recursive code. So what we are doing now is we are seeing how to solve recurrence relation. What are all the different kinds of recurrence relation we might get whenever we are solving a problem. Okay, so before getting deep into recursion, we are finishing the solving recurrence relation part, and then we will enter into recursion very deeply. Okay, so we'll just start from where we left actually. Yesterday what we did is that we took these three I think yesterday no I think the very first solving recurrence relation part, we started with these three recurrence relation, and using successive substitution method we were solving this recurrence relation. And in the next recurrence relation part, we have seen a new kind of recurrence relation where two recursive call like this have been provided and two base conditions were provided. So there what we did is that we converted the given recurrence relation into a quadratic equation. Then we found roots for the quadratic equation, and then we went with a different technique in solving the recurrence relation. So today what we are going to do is, today we will be taking a different recurrence relation. T of n is equal to T of n divided by 2 plus 1, where the base condition T of 1 is equal to 1. T of n is equal to T of n divided by 2 plus n, whereas T of 1, the base condition, is equal to 1. The third recurrence relation is T of n is equal to 2 multiplied by T of n divided by 2 plus n, where the base condition T of 1 is equal to 1. You might wonder, yesterday you took A, now you are taking T, this looks different. No, instead of A, I'm taking it as T, that's it. It is just easy for me to write. That is the only thing that I've written. This can be also taken as an is equal to an divided by 2 plus 1. A1 is equal to 1. An is equal to an divided by 2 plus n, whereas a1 is equal to 1. A of n, an is equal to 2 multiplied by an divided by 2 plus n, whereas a1 is equal to 1. So the same type of recurrence relation only. So here we are able to find dividing functions. Dividing function, you will come to know what is dividing functions, everything. Okay, fine. So now we'll solve these three recurrence relation one after the other. Okay, then we will at last we'll just come to a conclusion. Okay, fine. First of all, taking the very first equation, like T of n is equal to T of n divided by 2 plus 1. What we are going to do, we are going to follow successive substitution method. We are going to follow successive substitution method. Okay, so what is successive substitution method? We will be substituting the value of T of n divided by 2. We will be substituting the value of T of n divided by 2. Okay, so first of all, we have the value of T of n. So now what will be T of n divided by 2? What will be T of n divided by 2 equal to? When T of n is equal to T of n divided by 2 plus 1, then T of n divided by 2 will be n divided by 2 whole divided by 2, which means that this is converted to T of n divided by 2 square. Okay, 2 square, because 2 into 2, it means 2 square. Okay, so I'll be raising 2 square. Okay, so this is equal to T of n divided by 2 square plus 1. When this t plus 1, this is what the expansion of T of n divided by 2. Now if we take this and when we substitute in this formula, what will happen? I'll just copy down that, and instead of T of n by 2, instead of T of n divided by 2, we will be substituting this T of n divided by 2 square plus 1 instead of this T of n divided by 2. So when we substitute, what we will get? T of n divided by 2 square plus 2 we will be getting, plus 2. So this can be converted to T of n divided by 2 the whole square plus 2. 1 and 1 together added to give 2. Now what is the next step? Now you have t of n divided by 2 square. You have to expand this t of n divided by 2 square. How to expand that? T of n divided by 2 square have to be expanded. So t of n divided by 2 square plus, sorry, t square is equal to when you expand t of n divided by 2 square, what will happen? One more divided by 2 will be joining. One more divided by 2. So when one more divided by 2 is joining, what will happen? This becomes t of n divided by, so 2 square multiplied by 2. One more 2 is multiplied, so it becomes 2 cube. So n divided by 2, the whole cube. Okay, fine. Plus 1 will be there. Okay, 1 will be there. See, when this is n, this is n by 2. When this is n by 2, this is n divided by 2 square. When this is n divided by 2 square, then n divided by 2 cube. Hope you are able to understand the pattern that we are following. Okay. So now what we need to do is that we need to take the value of n divided by 2 square, this value, and we have to substitute in this formula. So I'll just copy this equation down, and let me take this intermediate result. Okay, fine. Now instead of t of n divided by 2 square, we have this value. So this value have to be substituted instead of this. So what will happen now? So this together will become 3. Okay, so this keeps on going up. So we will be carrying out the same substitution method for k times. When this is carried out for k times, what will happen? Generalize this pattern, generalize this into, we will be generalizing this as t of n is equal to t of n divided by 2 power k. 2 power k, we can able to see here. First of all, initially this is n divided by 2 power 1, then it was n divided by 2 power 2, and now this is n divided by 2 power 3. So it is this 3, this power is taken as, generally taken as k. And if you're able to notice, if this is 2 power 1, this is 1. 2 power 2, this 2 is taken here as 2. 2 power 3, then this side is taken as 3. So whatever this value is, the same value is again coming here also. So if this is k, then again this next term is also k. So plus k. Okay. So t of n divided by 2 power k plus k. So after we generalize, we need to see the end condition. Yesterday itself I have told you that t of 1 is equal to 1. When t of 1 is equal to 1, it means that when n is 1, when the term becomes 1, then the value is 1. So the stopping condition is not 0 like yesterday. Now the stopping condition is 1. Okay. Maximum for dividing function, definitely the maximum end point will be 1 only. Okay. Because when you keep on dividing something by 2 or 3 or 4, you will not get 0. You can get maximum 1 only when you divide something by 2. That is why the end condition is like 1. So this entire term has to become 1, then only this entire flow can happen, because k times we are doing the same thing. K times means up to we reach 1, up to we reach 1. So this term n divided by 2 power k, n divided by 2 power k has to be equal to, n divided by 2k should be equal to 1. When n divided by 2k is equal to 1, then how, if we just take this 2 power k to the right hand side, what it will be? This is in division here, so it will go to multiplication. So n is equal to 1 multiplied by 2 power k, so which means that n is equal to 2 power k. N is equal to 2 power k. Okay, so when n is equal to 2 power k, what is the value of k? What is the value of k? The k can be, if you know mathematics very well, or otherwise you can just go and search. Actually, when n is equal to 2 power something, then this power can be taken as log whatever base you are writing, log base 2 here, because in the base you are having 3. Suppose if this is n is equal to 3k, then it will be log base 3. Okay, since this is, if n is equal to 10 power k, then k will be equal to log base 10. Okay, so here what I can say is k will be equal to log base 2, log base 2 log base 2 of n of n. Okay, see here, k is equal to log base 2. Okay, this base 2, log base 2 of n. Okay, mathematically this is a mathematical calculation that I'm doing. So if not, you can go and search about logarithm, and you can say that, see the you can see, check once that n, if n is equal to 2 power k, then k can be taken as log base 2 of n. So k value is log base 2 of n. So now what we can do? So always remember, whenever you in the recurrence relation you get n is equal to 2 power k, then k can be rewritten as log 2 of n. Always you remember, because this kind of thing only will be repeated. This kind of equation will be repeated in many recurrence relation. Okay, so now what we have to do? Instead of k we will be taking log 2 of n. So what I will do is t of n is equal to, I think this part, n divided by 2k. Instead of 2k, what we will do is we will take n. Okay, instead of 2k we will take n here. So when 2k is taken as n, so what this will be, t of n divided by n, plus instead of k we will be taking the value of k, which is log base 2, log base 2 of n. Okay, fine. So instead of 2k we are taking 2k is equal to n. So instead of 2k we are taking it as n, and now instead of k we are taking it as log 2 of n. Log 2 of n we are taking. Okay, so t of n is equal to t of n divided by n plus log base 2 of n. So what is t of n divided by n? So t of n is equal to t of 0, t of 0 plus log 2, log base 2 of n. Okay, log base 2 of n, log base 2 of n. Okay, fine. So what is the next thing that, okay, it's not t of 0, this is t of 1. N divided by n means 1. So what is t of 1? It is already provided. T of 1 is equal to 1. So this can be taken as, this can be rewritten as 1 plus log 2 of log base 2 of n, log base 2 of n, log base 2 of n. So this is the answer, final answer. And in this, among 1 and log 2 of n, which is the largest term? Log base 2 of n is the largest term. So the time complexity of this is, the time complexity of this recurrence relation is order of log base 2 of n, log base 2 of n. Okay, order of log base 2 n. So for the very first recurrence relation, we have solved everything using successive substitution. Now we will take the second equation and we will try to solve things very faster. Okay, so since already you know uh, already you have a good knowledge of what a successive substitution is all about, so I'll just try to finish this fast. Okay, fine. So now if you take t of n is equal to t of n divided by 2 plus n, now we will be going with successive substitution. It means that first of all we will be finding the value of n divided by 2. What it is going to be? T of n divided by 2 square. Similarly, in the previous way how we did the same thing, n divided by 2 square plus n divided by 2. So see here, if this is n, this is also n. If this is n by 2, then this also have to be n by 2. So you cannot again take n. Okay, so this is what the value of t of n divided by 2. So we are going to just substitute in this equation. So if we substitute in the above equation, t of n will be t of n. Okay, t of n will be equal to t, instead of t of n by 2, I'm going to substitute t of n divided by 2 square. Okay, 2 square plus n divided by 2 plus n, which is there in the formula. So instead of t of n divided by 2, we have substituted this entire equation followed by addition followed by n, which we have here. Okay, fine. So now what we have to do next we have to make one more substitution for the value of n divided by 2 square. T of n divided by 2 square. What is the value of t? What is the value of t of n divided by 2 square is going to be? It is equal to t of n divided by 2 power 3, 2 cube plus n divided by, if this is n, this plus here we have plus n term. When the argument is taking n divided by 2, here this term is n divided by 2. When now the argument is n divided by 2 square, then this also have to be n divided by 2 square. So n divided by 2 power 2. Okay, n square. Okay, so now what we have to do, we have to substitute the value of t of n divided by 2 square here in this. Instead of this term, this complete data have to be replaced. So I'll just take a copy of this equation. I'll just take a copy of this equation. Okay, and if you see, instead of t of n divided by 2 square, I need to substitute this entire value. So instead of t of n divided by 2 square, this entire value have to be replaced, and the whole equation becomes like this. Now we are going to, what we are going to do is we are going to generalize this equation. So two substitution we have done successively, and after doing 2 or 3 successive substitution, we have to go for generalizing. How to generalize this equation? We have done k time substitution. After k time substitution, it means after 3 substitution you are having 2 power 3. So this can be generally taken as n divided by 2 power k. How we are going to generalize this? I'll tell you. Okay, so before generalizing this, first of all I'll generalize this and I'll show you. I will show you only for this part. For this part, if you see, n is a common term in all these 3 terms, so I'll take n common outside, and inside if you see, this is n, this n is having only 1, so this is n of 1 plus, and here except n we are having 1 divided by 2, so 1 plus 1 divided by 2 plus, what is this? This is, if take n is taken outside, then this becomes 1 divided by 2 power square. So 1 divided by 2 power 2. Okay, so 1 plus 1 divided by 2, 1 plus 1 divided by 2 plus 1 divided by 2 square. This keeps on going up to what? If you see here, if this is 2 power 3, then this is coming up to 2 square. If this is 2 square, you are stopping up to 2 power 1. If this is 2, you are stopping with 1 itself, divided by 1 itself. So what you can say is up to k minus 1. If this is k, if this is taken as k, then this has to be taken as k minus 1. So when this 1 plus 1 divided by 2 plus 1 divided by 2 the whole square, when this keeps on going up to, okay, when this keeps on going up to, generally let me tell you, 1 minute. When this generally keeps on going up to 1 divided by 2 power k minus 1, then what has to be the answer of this 1 plus 1 divided by 2 plus 1 divided by 2 square up to 1 divided by 2 power k minus 1? This can be generally taken as 1. This can be generally taken as 1. How I'm telling that this can be taken as generally 1? I'll tell you. Okay, see, I'm not including 1 except 1. This 1 by 2, 1 by 2 square up to 1 by 2 power k minus 1 can be generally taken as 1. How? I'll tell you. For example, I'll just show you, we'll just take a circle. Actually, I'll show you the example of a circle. We have taken a circle. This is equal to one circle. Entire part is called as 1. Now I'm going to divide this circle into 2 equal parts. When a circle is divided into 2 equal parts, when a single circle is divided into 2 equal parts, now if you see this left side part, you can call this as 1 by 2 because half of the circle, right? So this is 1 by 2 part, and this will be another 1 by 2 part. Now what I'm doing, this another 1 by 2 part, I'm going to divide this into 2 equal parts. When 1 by 2 is divided into 2 equal parts, this becomes 1 by 4. So this is a separate 1 by 4 part, and this is a separate 1 by 4. Now what I'm going to do is this 1 by 4 part, I'm going to divide this into two equal parts. So when a 1 by 4 part is divided equally into two, then this becomes 1 by 8, each 1 by 8. So this is 1 by 8. So now what I will tell you is this part is equal to 1 divided by 8. Now this another part is equal to 1 divided by 8, but what I'm doing again, I'm dividing this 1 by 8 into two equal parts. So when 1 by 2 is 1 by, when 1 by 8 is divided into two equal parts, this becomes 1 by 16, and the other part also becomes 1 by 16. So this keeps on going, 1 by 2, 1 by 4, 1 by 8, 1 by 16, and 1 by 32. It keeps on going. So can you able to see here, 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 up to so on. Whatever you do, which will be equal to a single circle, which will be equal to a single circle. So 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 up to so on. Okay, up to 2 power k, because can you able to see here in the denominator, this is 2 power 1, this is 2 power 2, 2 square, this is 2 power 3, this is 2 power 4, then again 2 power 5, 2 power 6, up to 2 power k. So when 1 divided by 2 power k, it keeps on being added, then which will be equal to, this will be equal to, totally when you add all these things, this will be equal to 1, equal to 1. So what we can do here is, instead of this entire equation, 1 divided by 2 plus 1 divided by 2 square up to 1 divided by 2 power k minus 1 can be generally taken as positive 1. So if this is generally taken as positive 1, we have one more 1 there. So 1 plus 1 will be equal to 2. So this part totally becomes 2n. Which part becomes 2n? This entire part becomes 2n. So let me take it as 2n. So hope one part of it has been solved already. Now what is the other part? We have to generalize this. So t of 2 power 3 have to be changed to 2 power k. Now we have generalized the equation. When the general equation is generalized, what is the ending condition? And this ending condition is 1. 1, which means that n by 2 power k have to be equal to 1. So here n divided by 2 power k, n divided by 2 power k should be equal to 1. When n divided by 2 power k is equal to 1, then n will be equal to 2 power k, that already we have seen in the previous equation. Okay, n is equal to 2 power k. Now I have already told you that when such an equation is given, what will be the value of k? K will be equal to log base 2. Okay, log base 2 of k, log base 2 of k. Okay, log base 2 of n, log base 2 of n. So k value also we found. Now what we need to do, I'm going to substitute these values. So t of n is equal to t of n divided by, instead of 2 power k, what is the value of 2 power k? Value of 2 power k is equal to n. So n divided by, instead of 2 power k, n divided by n plus, I'll be getting 2n. Okay, I am just getting 2n. Fine. So what is this equal to? This is equal to, 1 plus, sorry, here this is equal to, because see here t of 1, what is t of 1? T of 1 is equal to 1 here. So 1 plus 2n. What is 1 plus 2? So 1 plus 2n is the equation that we get, which is the largest term. 2n is the largest term. So what is the highest degree here? Power 1. 1 is the highest degree. So only this part has to be taken as a time complexity part. So order of order of n is the time complexity. Order of n is the time complexity of this equation. Okay, fine. So we will go for the third equation also. We'll just go for third equation. So we'll just get a copy of this third equation and we will just solve this also, so that you might also get a clear understanding of how dividing functions can be solved. So this is the last and the third equation of the lecture we will be seeing. And what is this equation? Is t of n is equal to 2t of n divided by 2 plus n, where t of 1 is equal to 1. So first of all, what we need to do, we have to go for substitution, so that we have to find the value of t of n divided by 2. So what will be t of n divided by 2? If we expand t of n divided by 2, this is equal to 2 multiplied by 2 multiplied by t of n divided by 2 multiplied by t of n divided by 2 square, n divided by 2 square plus n divided by 2. Okay, plus n divided by 2, because as in the previous previous equations itself we have seen that this is n, this is n by 2, then again we have to go with n by 2. So this is a similar way of writing. If this is n, here this term is also n. If the parameter is n by 2, then this last term is also taken as n by 2. Okay, so when this is the value of t of n by 2, then this value have to be substituted instead of this t of n by 2. Okay, so 2 will be outside, so inside this 2 should be multiplied by this both these terms. I'll just show you here how to do that. So let me have a copy of this equation first of all. And now if you see t of n, sorry, t of n is equal to 2. So instead of 2t, instead of this t of n divided by 2, what has to happen is this entire term called 2 of 2 into t of n divided by 2 to n divided by 2 square plus n divided by 2 have to be given here, plus n. So now what has to happen, this 2 have to be multiplied inside both these terms. For this 2 of t of n divided by 2 square, as well as this 2 have to be multiplied to this term n divided by 2 also. Now how this will change, t of n is equal to 2 multiplied by 2 t power n divided by 2 square is equal to 4 t 4t of n divided by 2 square plus 2 multiplied by n by 2. What is 2 multiplied by n by 2? Which is equal, 2 multiplied by n by 2 is equal to 2 and this division by 2 both will get cancelled. The remaining answer will be n. So this is equal to n. And one more form in the one more term called n is there in the formula. That term also we are going to include. How this is going to be? This is equal to plus 2n. Now what is the next step? Next step, we should go for the substitution of t of n divided by 2 square. So t of n divided by 2 square is equal to t of n divided by 2 square is equal to 2t of n divided by 2q, n divided by 2q plus n divided by 2 square. Already we have seen here, if this is n, this is taken as n. Okay, see, if this is n, this is taken as n. If this is this is n by 2, then the term becomes n by 2. When this term is n divided by 2 square, then this term has to be changed to n by 2 square. So now we will just check. Okay, so now we have to substitute this entire term instead of t of n divided by 2 square alone. Okay, so now I'll just take this equation to substitute and we'll just go for substitution. So in this, what we have to do, instead of t of n divided by 2 square, I need to be substituting this entire values. So I'll just show you here. So bracket inside bracket. So now what has to happen, this 4 have to be divided inside for both these terms. So if when I multiply inside, what has to happen, 4 into 4 multiplied by 2 will become 8t of n divided by 2 power 3 plus 4 multiplied by n divided by 2 square. I think 2 square is what, 4. So 4 here, 4 is here in the denominator, 4 here is in the numerator. So both will cancel, and which will also again give you n. Plus in the formula, one more term called 2n is there, that also let me include. So n plus 2n will become 3n. This will become 3n. So this keeps on going. So now we are going to generalize this pattern. How we are going to generalize? See, if you look at this 2, first time it is 2, next time this becomes 4, the next time it is becoming 8. So is it multiplied by 2 again and again? So can we call this as 2 power k? Can we call this as 2 power k? Because here 2 power 1, here 2 power 2, here 2 power 3. So 3 is the number of steps we are carrying out. So this can be taken as 2 power k. So t of n, when we are generalizing, t power n is equal to 2 power k. This can be generalized as 2 power k, then multiplied by t of n divided by, again 2 power 3. So 3 is what we have made it as k. Here 2 cube, here 2 square, then here 2. So this 2 power 3 also can be converted to 2 power k, generalizing it 2 power k. Okay, fine. Plus, what is this? N, 2n, 3n. This can be taken as kn, generalized as kn. So 2 power k multiplied by t of n divided by 2 power k plus kn. This is a generalized equation that we get. In this generalized equation, if you just see, look at this. What is stopping condition? T of 1, which means this entire term has to become 1. So what we can say is n divided by 2 power k, n divided by 2 power k is equal to 1. N divided by 2 power k is equal to 1, then n is equal to 2 power k. N is equal to 2 power, n is equal to 2 power k. Okay, n is equal to 2 power k. Okay, n is equal to 2 power k. So when n is equal to 2 power k, already I have told you what will be the value of k. K will be equal to log base 2, log base 2 of n, log base 2 of n. So using these values, we will just substitute here. So t of n is equal to, what is 2 power k? 2 power k can be taken as n. So 2 power k means n. So n, t of n divided by, again 2 power k is coming, so where I can substitute n instead of 2 power k, plus now k is coming. So instead of k, we can go with log base 2 of n, then multiplied by one more n, multiplied by n. So this we can take it as n log n. Okay, here this n, instead of k we are substituting log to n, so this is can be taken as n log n. Okay, so we will just go with this value. So what will be t of n divided by n? T of n divided by n will be t of 1. Okay, t of n. So t of n is equal to n multiplied by t of 1. What is t of 1? T of 1 value is 1. Already we have it here. T of 1 is equal to 1. So 1 multiplied by n is equal to n plus n log base 2 n. So this is final equation, which is n plus n log n. So which can be taken as, which can be generally taken as, order of n log base to n, n log base to n. So this is what called as n log n. So n log n solution. Okay, fine. So far we have seen many recurrence relation, and we have seen also many time complexities also. For example, we will just start with order of 1. We have seen order of 1 equation. Okay, we have seen order of log n equation. We have seen order of log n equation. Okay, we have seen order of log n equation. Then we have seen order of n equation. Also we have seen order of n log n equation. Sorry, yes, order of n log n equation. Then we have seen order of n square equation. N square equation. Then we have also seen order of 2 power n equation, or 5 power n, 2 power n, 3 power n, that category. So these are all the main equations, main time complexities that we have seen so far. And in the very next lecture, what I will be doing is that I will be comparing order of 1, order of log n, order of n, order of log n log n, order of n square, order of 2 power n. I'll be analyzing all these time complexities one by one by plotting it in a graph. By plotting it in a graph, we will just decide which is actually the efficient time complexity, and which is going to be worst time complexity. Okay, so the next part is going to be analyzing the time complexity, analyzing the major time complexities like order of 1, order of log n, n log n, n square, and 2 power n. Okay, the next part is going to be very important for the for the upcoming parts. Okay, so keep watching. This is it for this session, and thank you.